Hey guys, and welcome back. Today we're going to take a step beyond the lines that are parallel cut by a transversal, and we're going to venture into those lines creating triangles where we can examine their interior and exterior angles. The learning target is, again, to use informal arguments to establish facts about the angles created on the interior and exterior of a triangle. So when it says formal arguments, that just means we're going to need to justify our answer in words. Our success criteria, I can identify interior and exterior angles of a triangle. We're going to do that specifically by a definition, not just where we think they are. Second, I can apply the triangle sum theorem. Okay, triangle sum theorem and the exterior angle theorem. These are going to be mathematical rules that you can apply when given certain pieces of information. And then lastly, I can use angle relationships to find unknown angles. So we're going to be looking for angles that may be marked with a variable or may have been left blank. So let's take a look at the key idea here. Interior angles of a triangle I have highlighted here in green, blue, and yellow. These are angles inside the triangle created by the sides of the triangle. And we can use the triangle sum theorem, which you should know from 7th grade, is the sum of the three angles of a triangle add to 180 degrees. So specifically in this picture, it would be that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 all equals 180 degrees. Okay, and we can do that, we can use that equation to find unknown angles by subtracting the other two. Okay, so we're just going to subtract known angles from 180 to obtain the unknown. Okay, so let's take a look at the first example. It says find each unknown angle measure. So I have these triangles where one of the angles is grayed out and circled. That's the angle that we're trying to find. So in this first one, we're going to find the measure of angle 1. Well, all you need to do is add all three angles together. So 43 degrees plus 32 degrees plus the last angle, which is the measure of angle 1, is equal to 180 degrees. So now I can combine my like terms. Remember, like terms are numbers with the same variable attached to them, or if there are no variables, those are like terms to each other. So I cannot combine the 43 and the 32 with the statement measure of angle 1, but I can combine 43 and 42 together to make 75. So 75 plus the measure of angle 1 is equal to 180 degrees. And in order to now solve for the measure of angle 1, we need to get rid of what's being added to it, which is 75. So I'm going to subtract 75 degrees from each side of the equation. Okay, so now my 75s are gone, and I'm left with the measure of angle 1 is equal to 105 degrees. Okay, so really that last step there, this one right here, is showing us that we can actually keep most of the work in our calculator if we add the two other angles together and just subtract them from 180, we get what's left over. So that's what I'm going to do in my calculator for the last three triangles. Follow along with me in your calculator. I'm going to first do 59 plus 21, which is 80. And then in my calculator, I'm going to type 180 minus 80, and that's equal to 100 degrees. So the measure of angle 2 is 100 degrees. I'm going to do the same thing for this third triangle. 50 plus 45 is equal to 95. And then 180 minus 95 is going to equal 85. So the measure of angle 3 is 85 degrees. Last one, 65 plus 20, that's equal to 85. 180 minus 85 is equal to 95. So the measure of angle 4 is 95 degrees. Why don't you guys give this a try in your own triangle, in your U-try? It says, what is the measure of angle F? All right, so in this example, we're going to have to find all three unknown angles, but we're only going to know the ratio that the angles have with each other. So it says the measure of the angles of a triangle are in the ratio 2, 6, 10. Find the common multiple x of each angle. That is an instruction that I have inserted. That will not be on the test, but that's my little hint to you, is that there's a common multiple of all three of these numbers, x, that you can apply to find the measure of each angle. So let's give ourselves a visual. Okay, so here's my triangle. What this is saying in this ratio is each of the angles has that number in it and is being multiplied by a common number, x. So this could be 2x, 6x, and 10x. Those are the three angles, and their numbers are being multiplied by some common number. Well, we know that all the angles of a triangle add to be 180 degrees, so 2x plus 6x plus 10x is equal to 18x. So since 18x, not 18x, is 180. If we combine the like terms, that's what I was meaning to write. When we combine those like terms, 2 plus 6 plus 10, that's 18x. And all three of those have to add to 180 degrees. When we divide by 18 to get x all by itself, we get that x is equal to 10. Now that's just x. We need to plug x back in to the x's in all of the expressions of each angle. Okay, because it says to find the measure of each angle. Okay, so it doesn't just say to find x. So let's call this triangle A, B, and C. The measure of angle A is going to equal 6 times x, which is 10. 6 times 10 is 60. The measure of angle B says it's 10 times x, which that's 10 times 10, which is 100, because x is equal to 10. And then the measure of angle C is equal to 2 times x, and x is 10, so 2 times 10 is 20. So those are the three measures, the three angle measures of this triangle that has a ratio of 2, 6, 10. So let's have you guys give this a try in your U-try. Alright, so the second key idea here is that there are angles that can be created on the outside of a triangle as well. Particularly, an exterior angle is formed by, and this is really, really specific, really, really important, formed by a side of the triangle and an adjacent side's extension. Okay, a lot of students accidentally mix up an exterior angle when it's made up of two extensions, but it has to actually be connected to the triangle itself, like angle 3. Okay, notice how this is an extension, and then this is the side of the triangle itself forming that angle. Okay, if I created another extension, okay, this would not be an exterior angle. Okay, so I'm just going to put a little note there, not an exterior angle. It's on the outside of the triangle, we just don't call it specifically by definition an exterior angle. The exterior angle theorem says it's equal to the sum of its two remote interior angles. Now I'm going to highlight the word remote. Okay, remote meaning furthest away. So I'm going to write furthest away or non-adjacent. Okay. Remember, adjacent means next to. So the one that's not next to it. So this guy right here is not a remote interior angle. It's angle 1 and 2 because they're further away from angle 3 and they're not sitting right next to it. Okay, the theorem says that angle 1 and angle 2 add together to equal angle 3 on the outside. So let's give this a try in the third example. It says, which of the numbered angles are exterior angles? So I'm just going to go through my diagram and name the ones that are made up of an extension and one of the sides of the triangle. Okay, so in this top intersection here, I'm seeing angle 7 is created by a side of the triangle and its own side's extension. The definition specifically said that it had to be of an adjacent side's extension. So angle 7 is not an exterior angle. Angle 5 is definitely on the interior, but then if we look at angle 8, I do see an extension and then the side of an adjacent side that is part of the triangle. So angle 8 is an exterior angle. Okay. Now when we look down at this intersection down here, I see 4 is definitely an interior angle, and then 2 is not an exterior angle. That's what I was talking about in the last example. It's made up of 2 extensions. So the other 2 exterior angles are going to be 1 and 3. And then lastly, in this intersection here, 6 is definitely an interior angle, so the only exterior angle there is 9. Now we're going to name the remote interior angles for each exterior angle. So just focusing on angle 8, I don't want to pick the angle that is next to it on the inside of the triangle, but I want to pick the other 2. So the 2 remote interior angles to angle 8 is 6 and 4. Okay, now if I just look at angle 1, I do not want to pick the one adjacent to it, so it's 5 and 6. Angle 3 is actually going to be the same thing because 3 is also adjacent to 4. And then lastly, angle 9 is adjacent to angle 6, so the remote interior angles to angle 9 would be 5 and 4. And as a little extension says which exterior angles are congruent and explain, I can definitely see some similarities between angle 1 and angle 3. Okay, measure of angle 1 is congruent, or I shouldn't say congruent, is equal to the measure of angle 3, or angle 1 is congruent to angle 3. You could write that either way. I can tell because it has the same remote interior angles. Okay, and the exterior angle theorem says that those 2 remote interior angles add to equal the exterior. I can also tell because angle 1 and angle 3 are vertical. That's another reason why they are congruent to each other. So we can see that they also share the same 2 remote interior angles. Let's have you give this a try in your third U-Try. It says, what are the remote interior angles relative to the exterior angle 1? So you're looking at this angle right here. You're going to tell me which angles are the 2 remote interior, A, B, or C. All right, so I've got one more example here to which we're going to find either unknown exterior angles or unknown interior angles using the exterior angle theorem. So let's take a look at this first example here. Remember that that blue square is signifying to you that that's a 90-degree angle. So just remember the two remote interior angles. Okay, so those two are the remote interior. Okay, those two add together to equal the exterior angle. Okay, so I'm going to take 34 and 90, add them together. That's going to be 124. So 124 degrees is the missing angle. Okay, so all you're going to have to do for if you need the exterior angle is add the two remote interior angles together. So the other triangle that is missing the exterior angle is this one over here. Okay, so all I'm doing is taking 53 and 61 and I'm adding them together, which is 114. So 114 is the measure of angle 3. Okay, I'm going to rewrite it that way over here. Measure of angle 1 was equal to 124. Okay, now in the other two triangles, they're missing an interior angle. So if we write down what the theorem says, that the two remote interior angles, that's 43, plus the unknown, so the measure of angle 2, has to equal the exterior angle, which is 71. So really, I'm just taking that 43 that's being added to both sides of this equation, and I'm going to subtract it to get the measure of angle 2 all by itself. So now I have the measure of angle 2 is equal to 71 minus 43. That should be 28 degrees. So that's what goes up in there. Okay, so really on this third step, we're just taking the known interior angle and we're subtracting it from the exterior angle. So really I can just do a quick little calculation here because I'm again looking for an interior angle. This one is the exterior angle, and again that would be 90 degrees. Okay, so I have the exterior 90 minus the known interior is going to equal the other interior angle, which in this situation is 17 degrees. So that's the measure of angle 4. Okay, so now using this exterior angle theorem, I want you to try this on your own on your fourth U-try. What is the value of x? And again, rewrite your exterior angle theorem. All right, I got a couple of last close and check questions for you to make sure you really understand what's going on. These you answer on your own, and I will review and grade them in the Edpuzzle. Please make sure though, if you're having trouble with these, ask questions, get some help. Go ahead and give these a shot. All right, so just to recap what we've been doing today, we've been using informal arguments to establish facts about the angles created on the interior and exterior of a triangle. We did that one by identifying interior and exterior angles on the triangle. That was example 1 and 2. We also applied triangle sum theorem and the exterior angle theorem. That was also on example, I believe we did 2 and 4. And then we also, throughout the entire thing, so all examples, we were using angle relationships to find those unknown angles in each of the triangles. Okay, so please make sure you go back and rewatch any sections you may have been unclear with, ask any questions you need for further clarity, and go ahead and start your homework.